Hey, good morning, everyone.
Good morning, Professor.
Hey, good morning, Angelica.
Morning,
Uh,
Professor.
hey, good morning, Naomi. Good morning. Well, glad to see you on this sunny morning. It's been a while since we had this kind of weather. So I see 7 people. Uh, so let me check how many are on in today's. Okay, so I have 7 in today's forum and also 7 here. So good, numbers match. At least Um, so in our last class, we talked basically we looked into uh, the examples of basic concept of annuity and free-form multiple cash flow model. I mean, free-form multiple cash flow model, um, it's really ad hoc. I mean, everything is ad hoc, right? In other words, the amount deposited and the interval, right? And the interest rate or are all ad hoc. In other words, it could be a random thing. It's a random thing. So there's no uniform or consistent uniform formula, algebraic model to represent it. I mean, we can do it one by one, but not the one that can um, capture everything in a uh, simple model. Well, on the other hand, annuities, right? Um, the concept of annuity we already understand, and it can, and then all these separate processes can be all truncated. It can be all captured in a single formula. Why? First of all, I probably said this before in our last class, that this example is a very simplified version, extremely simplified example. Uh, but think about it. Who in reality, the timeline is not this simple. I mean, it can be 5 years, but monthly payment, monthly deposit, monthly payment. Even if it is annual, I mean, if the timeline is for 30 years or 60 years, it won't be this simple, right? It will be a very long, lengthy polynomial, uh, which isn't impossible. I mean, it is certainly not undoable, but it just becomes very tedious to do it like this. So when we can just truncate this into this formula. This is the formula for future value of annuity, and then um, as an example, I will explain how the steps of derivation, how I got to this. Um, but for now, so as a practical example, right? Let's take a look at this example as a practical example. So let's say you have a plan. You have a plan for graduate school. So you want to go to graduate school in 5 years, and you want to of course, after bachelor's, and also to take and your goal is to earn MBA degree, MBA in so let's say preferably MBA in finance or MS in finance. Now, graduate schools cost, and of course, in top tier schools, prestigious, renowned schools like, Ivy League or top, even, top tier, or even, just, state universities. It will cost anywhere between 40K to 60K, and that's a year. So for 2 years, it would cost it could cost on average like 100K. Now this is it could be it could be so obviously you're looking for on more affordable solutions. So you look into CUNY, and of course CUNY being the most affordable school, you'll find most likely, I don't know, I haven't checked, but my assumption is that the MBA 2 years, for 2 years at CUNY, at Zicklin School, right? Baruch Zicklin School, it would cost probably 60K for 2 years. Okay, so so then our next question is, how do you pay for it? In other words, of course it will have to come out of your pocket unless you get a scholarship. But in MBA programs, there is no scholarship, and maybe CUNY, in CUNY maybe that's possible, but in most cases, MBA program is a big business for universities. I mean, they will pay out of their own pocket to get MBA, especially in private schools, but CUNY may have some financial aid, but basically it will cost at least 60K out of your own pocket. So then, how do you finance it? Okay, how do you finance it? So there are two options. One, if you have a large lump sum like 40K today, or 50K. Now let's say 40K. If you have 40K and your timeline is 5 years, so if you put it in a bank, and if the bank interest rate is good, over 5 years, it may grow to 60K. But it's just a wishful thinking. The question is really, first, who has 40K? First, right? Who has 40K? That's a good question, right? Some of you may, but when most of you must be around, just about 19, 20, 21, 22. And at that age, who has like, 40K in the bank account, right? When I was 20 years old, I had at most, $1,000 in my name, in my bank account. And that was almost 60 years ago. So I mean 40 years ago. I'm sorry, 40 years ago. 60. That was 40 years ago, and then $1,000 in those days. $1,000 in those days felt like $10,000 today. But actually, adjusting for inflation over 40 years, it would still be not more than $5,000 today. But anyway, the point is, one, if you have a lump sum, large lump sum, like 40K, 50K, you can put it in the bank and wait for it to grow to 60K. But then it depends on the interest rate, right? You all understand. It all depends on the interest rate. Second, you can save like $800 every month. Okay, you can make a deposit of $800 every month over 5 years like this. But of course, then there will be on the timeline, there will be 60 notches, right? Not because it's monthly. So first month you start with 800, second month, third month, there will be 60 of them. And there's no way you can do it like this. There's no way you can find the future value this way, because it's going to be very tedious. It's going to be a lot, the math itself isn't difficult, but then it will be a tedious job. So that's why we use this formula. And then now let's think about it. So if you have a part-time job, right? If you have a part-time job, and so you can save at least $800 every month. That could be possible. And if interest rate is currently 6%, so in other words, you must this cannot be done without opening an annuity account, right? Because if you open an annuity account, you will get a better interest rate. And in reality, we all know the bank interest rate these days is just about only about not even 1%. So it's all hypothetical situation, assuming 6%. But 6% isn't too hypothetical, because 6% is the historical average, right? Historical 6% is the historically most historical average of interest rate. I mean, as long as we have interest rate data, right? And I probably said, even in the ancient Roman, ancient Egyptian times, biblical records indicate even biblical time. Most, it's not data. It's just an account in some, biblical biblical literature, right? Biblical literature from biblical times. It's like chronicles. In those days, they all record, chronicles. So it cannot be quite called data, because data should be tracking, interest rates monthly, quarterly, annually. But then in those days, still, in the anecdotes found in those biblical scriptures or biblical literature, still chronicles, right? Biblical chronicles still most commonly quote 6%. And even through medieval times, pretty much the average was around. But since about 19th century, then they started to record these data in the literal sense of the word data. They recorded interest rate trends, and if you can get a hand on those 19th century documents, recording the interest rates, by month or by year, and then combining all that data with the modern data, we take the average, still comes to something like 6%. So anyway, now think about it. If you can save like $800 every month for the next 5 years, then there are all how many months? 60 months, right? 60 months. So the deposit or loan, I mean, some of all the deposits are like principal, right? Because, but not made at time zero. They are all made at different points: time one, time two, time three, time four. That alone is 48K, isn't it right? Think about it. 800 times, 800 times 60. That alone comes to 48K. So if the interest rate is right, then you may be able to achieve that target goal of 60K. Make sense? So let's try to do this. And to do that, we'll use Excel. This is okay. Where's my? Okay, I'll have to go to. All right. So I want you to open this file. Okay. I want you to open it. Um, you downloaded this file last time because we've been working on this. We've been using this. We've been using this file for a while. And then when you open it, then you'll need to find this bottom tab that says multiple cash flow. Okay. Open the bottom tab that says multiple cash flow. And then delete everything in the highlighted cell. Please delete everything in the highlighted cell. Okay, delete everything in the highlighted cells. So, and if you take a look at row 2, that's exactly our example. Okay, the payment is $800, APR 6%, 5 years. M is 12, so it's monthly, right? Compounding frequency is monthly. So let me just first verify. Let me just confirm. So everyone has this file in front of you? Angelica, do you have this file
Yes.
in front of you?
Yes.
Okay, good. Fahad, do you have this file in front of you? Fahad? Jeremiah, do you have this file in front of you?
Yes.
Good, good. Carolis, do you have this file in front of you?
Hey, Professor.
Hey,
Yes, I do.
Nikori. Okay, so you both answered at the same time. Nikori, do you have this file in front of you?
I'm not sure
Nikori?
if you can hear me, but I'm having a problem with my computer, so I'm gonna just turn it off and on. I'll be
Oh,
back in
okay.
class in a few minutes.
Okay. Hopefully. So, Maricel, do you have this file in front of you, Maricel? Do you have this time value
Yes.
file in front? Good, good. So, have you deleted all the highlighted cells? You'll need to delete all the highlighted cells. Okay. And Naomi, do you have this file in front of you? Naomi?
Yes.
Good, good. Now, Nicole, do you have this file in front of you, Nicole?
Yeah, I
Nicole?
have it. I have it.
Good, 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 good. Noel, do you have this file in front of you? Noel? Okay, then I'll skip to Vivian. Vivian, do you have this file in front of you?
I'm so sorry. My mic was messed up. Can you hear me?
Yeah, I can hear you.
Yeah,
So you have this file in
I got
front
the
of
file. I'm sorry.
you? Okay, great.
I have
Vivian,
it
do
as well.
you? All right, great. And please make sure you have all those highlighted cells deleted, right? So, as I said, this is our example. So, we'll use the formula. But first, we'll need to find the periodic rates because obviously, if the because you're making monthly deposits, right? Monthly deposits, and each deposit will earn interest monthly, compounded monthly. So actual rate will have to be, we know that already. If you divide it by 12, that's going to be 0.5%. We'll just want to, and then how many compoundings? Of course, there's going to be 60 of them, right? 60 payments, uh, 60 compoundings. And I've told you, I said in the last class that deposit and payment are just the two sides of the same coin, just like the two sides of the same coin. So uh, there's no need to distinguish between the two. You can just call them, and the symbol for uh, deposit or payment is this payment, PMT. Okay, no distinction between the two. So here we're gonna use this formula, right? And the formula I wrote it here, but also you can um, uh, so also in the also in the PowerPoint. Now, so it's payment times open parenthesis open double one plus r, okay, raised to n minus 1, close parenthesis, divided by r. Okay? And if you're okay up to this point, then hit enter. And what did we get? We got 55K $816. So some people may say, "Yay, I've got it." No, that's not the. You didn't get it. I mean, my professor, what do you mean? Did I get the future? Yes, you got the future value of those $800 annuities for 5 years, but you haven't hit your target yet, isn't it right? We're still about $4,000 short of our target future value, right? Yeah, we're still $4,000 short. So then our next question is then, we need to hit 60K. So what else can we do? Then there are three other options. One, you increase your monthly deposit to by $50. You increase it by $50, right? Or find a bank that pays better interest rate. And hypothetically, let's say you found a bank that pays 8%. But in reality, um, you would know that it's not easy to find a bank that pays a superior interest rate, significantly better interest rate. Why? Again, banking is a very competitive industry. So one bank cannot pay significantly different interest rate from another. You might say, oh, 8% is significantly different from 6%. Yes, of course. 2% different is 2 percentage point. Now think about it. From 6% to 8%, that's actually 33% increase. 33% better. You understand what I'm saying? Hmm? Now, let me, I'm not sure, well, you should be able, I gotta use whiteboard. And then let's think about it. So what I'm talking about is um, we all know the difference is only two, but think about it. This is called, this difference is called the percentage point, 2 percentage point, right? If interest rate changed by 2 percentage point, right? That means, from 6% to 8%. But actually, this 2% difference is 1/3 of 6%. Isn't that right? 1/3 of 6%. 1/3 is like 33.33, right? It's 33%. So this difference is like 33% difference. You understand? Which is a huge difference, right? Everyone understands that? Hmm? This difference, when you say 2%, that's 2 percentage point. 2 percentage point, right? It's called 2 percentage point. But in terms of magnitude, is 33% difference, 33% growth, right? 33% change. The change is, the magnitude of change is 33%. Okay? Does everyone understand that now? Does everyone understand it? And therefore, it's a significant difference. All right? It says my connection is poor. But can everyone hear me?
Yes.
Okay, good, because it was saying my connection is. So everyone understands the difference between percentage point and percent, right?
Yes.
Okay, good. So think about it. Um, we're just assuming that you found a bank that pays 8% interest rate, and you might wonder, is that significantly better? Um, it's only 2% difference. Actually, you should say 2 percentage point difference. Uh, in terms of real, magnitude of change or magnitude of difference, it's 33%. Is 33%. So it's a significant difference, actually. And in a very competitive industry, right, this much difference is, really rare. I mean, where would you find the price differential of 33%? It means, you found a store, Apple store, where they sell all Apple products at 33% lower price, right? And that's not likely. Now, so a first option is increase the monthly deposit to 850, like $50. Second, find a bank that pays better interest rate. Option number 3, you extend the timeline. And under all of those scenarios, let's find out. And you don't need to solve it all over again. all you need to do is just simply copy, right, these three cells all at the same time and just drag it down. Okay, then you will have automatically, and this is not copying somebody else's work. You did it, you solved it yourself, right? If you solve at this time, I solved it. It's me who solved it, but if you encounter problems like this, at least the first problem you will have to solve yourself. And if the rest of them are problems of the same pattern, you can just copy and paste, right? Because it's your own work. You're copying and pasting your own work. It's not plagiarism. So, did everyone get the same result? Did everyone get the same result? First of all, okay, good. Now, when we increased our monthly deposit by $50, we are quite close, but we are still about $700 short. Right? We're still about $700 short. And then, oh God, my chair is creaking like, I gotta use WD. And then, even at 8%, you're still about $1,300 short. Only when you extend your timeline to 6 years, then you'll have more than enough money. In other words, you overshoot the target. Now, you might think, number four is the best option. No, it's not the best option. Why? Because you will have to postpone your graduate school by 1 year. I mean, this timeline is also, this timeline is a kind of realistic timeline. Why? First of all, it will take 4 to 5 years to graduate with your bachelor's. 4 to 5 years, at a minimum of 4 years. Even if you graduate in 4 years, right? Very good, renowned, reputable MBA programs require some work experience in the corporate environment, right? In the corporate center. Not the work experience doesn't mean working in McDonald's or Burger King or Pizza Hut. Of course, it's a different story. If you worked at the corporate center, McDonald's corporate center, or Pizza Hut corporate center, it's a different story. But what I'm talking about is the work experience. Only the work experience at large corporations will count as experience. And these days, reputable MBA programs require work experience. So, let's say you graduate from college in 4 years and luckily land a job, a corporate with a large corporation, and work for at least 1 year, and then then you get admitted to MBA programs. So you go to so that's minimum is 5 years with the work experience. The minimum time is 5 years. Now, if it is 6 years, still a reasonable timeline, right? You may have graduated in 4 years from college and have 2 years work experience with a large corporation, or you may have taken 5 years to graduate from college and 1 year work experience. So it's all plausible scenario. But again, If possible, all of these scenarios are valid. Now the next question is then, uh, so instead of overshooting or undershooting the target, these are all undershooting, right? You undershot the target, you overshot the target. Is there any way we can shoot the target exactly on the head? Is there any way we can nail the target future value? Yes, we can actually find the exact payment, right? That will exactly hit this target. How do we do that? I'll get to that a little later. But first, let's think about what this is. This is annuity due. This is annuity due. And do you remember last time I talked about the difference between the two, ordinary annuity and annuity due? So do you remember the difference? What did I say is the difference between the annuity due and ordinary annuity? I said the only difference between the two is one more compounding, right? It's not one more payment, it's one more compounding, right? Get it right, please get it right this time, because some people confuse it. As one more compounding. No, both ordinary annuity and annuity due, they both have same number of payments, right? But the only difference is one more compounding. The first deposit in annuity due, in ordinary annuity, the first deposit will earn interest n minus 1 times, right? It's 5 years, n is 5. But the first deposit gets compounded 4 times, n minus 1. And then this is n minus 2 times, n minus 3 times, n minus 4 times, right? N minus 5, n minus n, right? The annuity due earns interest one more time every time. The first deposit earns interest 5 times, which is n. Second one, 4 times, right? And so on. So the difference between the two is exactly one more compounding. So here, this is ordinary future value of ordinary annuity, and this is the future value of annuity due. Well, what do you see? It's the same formula. You just have one more, 1 plus r. So one more compounding. Okay? With that in mind, then since we already have ordinary annuity, future value of, we already have that. So then what do? We recycle. And simply recycle this. And then times, give it one more compounding. There you go. You have one more compounding. Okay? And then the rest of them, all you need to do is just drag it down. And you have the future value of annuity due. Okay? All right, then then the next question is, how do we nail the exact payment then without, this is called, doing it this way, it's called a trial and error method, trial and error. Okay, usually the trial and error method is, okay, so if future value is still, deviating from the target, let's try 850. You increase this, right? And then we get closer, but still not quite there. So we increase this by $10. So increase it, so 860. And if you actually do 860, it will overshoot our target slightly. So we are close. Then it's something lower than 860. So let's try 890 then. I mean 859. So we try 859. It will be slightly below the target. Then it must be a number that is between 859 and 860. And so it's an iterative process. You reiterate the same process with different numbers, different inputs, different candidates. But then this is going to be a very tedious process and not very scientific process, right? Trial and error method is even, what cavemen can do, right? Even the caveman, the primitive human can do, right? Because it's either it's either this or either that. And let's say you are fishing in the pond, right? You cast your you cast your rod, or whatever you call it, cast your rod or the fly or bait, to the right, no fish. Then you adjust it a little to the left, no fish. But um, then you see the fish between your right and left. You narrow the fish. You saw the fish jumping, so you narrow you move your rod a little to the right, and then you see the fish jumping. Actually, the fish was jumping actually to your left, and you move the rod a little to the left. And in other words, you narrow down the possible range, right? Through that reiterative process, through trial and error. Again, then this fishing, casting the bait or the fly through this repeated, reiterated process is something that even a caveman can do, right? So that's not how we're going to do it. We're going to exactly solve it mathematically, okay? Although some textbooks still suggest trial and error method, but then they should shame on themselves. The authors must shame on themselves. Why not, um, as academics, and any discipline that uses math, that is based on math, must be scientific. And just recommending trial and error method. First, you'll have to guess some number, right? And then narrow down the range, right, around the number, around that guess. That's not very scientific. So if any textbook is suggesting trial and error method, then they must, the authors must shame on themselves, right? But we're going to solve it mathematically. And oh, the time is already 11:48. So I think this is right about time to take a break. So we're going to take a 10-minute break and reconvene at 12. Okay? All righty, so let's go, let's take a 10-minute break. All right, we're back. We're back. So, let's see. So the so our question is now, how do we nail the exact payment, right? And we can easily do that mathematically because um, think about it. This is the formula for future value of annuities, right? For and then think about it. Um, I'll move this around. Maybe not. I'll just leave it there. So, um, and I've been telling you over and over that the key to solving any equation, no matter how complex they may look on the surface, right? But the key to solving all equations is to identify the z equals x times y structure. Z equals x times y structure, right? We've seen it repeatedly over and over. And then if you look at this equation, it's already presented in the z equals x times y structure because FB this is z, FBA is future value is the z, payment is x, and the rest of them is r, right? Because think about it, although it's written this way, right, as if payment is in the numerator, but we know that multiplying something to a fraction is always done by multiplying that number, that variable, only to the numerator of the fraction. So it's just like actually payment times, right? Payment is like x. The rest of them is y. Okay? Payment is x. The rest of them is y. Okay. Then we can just like we solve for x, just like we solve this equation for x, right? Which is then z divided by y. We do the same thing. We solve it for payment, and then payment is then FVA divided by the whole thing. But then y is now a fraction. You all know dividing something by a fraction is the same thing as multiplying by the reciprocal. Therefore, this is what it is. I did FVA times the reciprocal of y, the thing in the bracket. And then what's in the bracket? The thing in the bracket is r over 1 plus r. The thing in the bracket is 1 plus r raised to n minus 1 over r, which is the reciprocal of which is this. Okay, so now we have a formula to nail the exact payment. So we do, okay, so then we can do this. So our target future value is 60K. 60K times R, it's blank now, but it's going to be filled in after I put in the whole formula. R over, open parenthesis and open another one, 1 plus R raised to n minus 1. Okay, here you go. And of course, you won't see any result just yet because nothing is here. But as soon as we get right, as soon as we find those variables, right, it's going to be automatically right. So what do you see here? 859.97. It's almost 860, right? Did we see that when we increased our payment by $50, we were close, but still we were the closest, right? This option was the closest to the target, but still about $700 short. So I said, if he raise it to, then change it to like 860. If it is 860, then I said it will slightly overshoot the target. Yes, it will slightly overshoot the target because it's every monthly payment is 3 cents less, right? So we nailed it, right? So everyone got this number? Everyone? Let me know if you did, if you had any problem. Please let me know. You're awfully quiet, so I'll have to check one by one. Angelica, did you get that number? Did you get the same number?
I did, yes.
Okay, great. Yeah, I thought you would. Jeremiah, did you get that number? Did you get the same number, Jeremiah?
Yeah.
Okay, good. Carolus, did you get the same number? Carolus. How about you, Maricel? Did you get the same number?
Yes.
Okay, good. All right, I'm gonna skip the rest of, but the remaining 4 people, I'm gonna ask the next question. So let's do another example. This time, still the same target future value, right? Target future. And then this time, interest rate is 7.5, same 6 years, but compounding is quarterly. Then, it's not a difficult thing. All you need to do is simply, first, let's find the periodic rate. And how many quarters? It's going to be 24 quarters. Okay. And then you can do the same thing, right? I can copy this and paste it here, but just to get you, just to help you get the hang of it, let's do this. It's FVA times R over, open parenthesis, 1 plus R, so N minus 1 close parenthesis. Okay, you're okay up to this point, everyone? Hit enter. It's going to be slightly over 2,000. Yeah, it's $2,002.52. Okay. So, how about the rest of the group? Naomi, did you get the same number? Naomi, did you get 2002?
Yes.
Okay, good. Nicole, did you get the same number? Nicole?
Yeah, I got it.
Great. Noel, you got the same number? Noel?
Yeah, I got the same number.
Okay, great. Vivian, did you get the same number? Vivian?
Yes.
Okay, good. So I think we are all good here. Next question then. All right. So if we all understand that when an equation has x number of variables, right? When an equation has x number of variables, then there can be also x number of unknowns or x number of questions. So let me, am I still sharing my screen, right? So let me try, let me try this. I hope this will work. Because it's so annoying to switch between sharing screen and share the whiteboard, provided by Blackboard. It really takes a lot of time to open it. All righty. Okay, I guess I can. Well, just for your information, I couldn't get my computer fixed just yet. So no whiteboard, I mean, I miss the whiteboard, but no whiteboard for now. And I took it to the Geek Squad, and they said, they will have to reinstall everything. That's going to be and then even, they say, it's going to take anywhere between 1 and 7 days. That's crazy. Also, they said it's going to cost me $400. Well, I would rather buy a new computer. So I'm still exploring other, anyway, so green, talk blue, I guess, blue. All right. Okay, is there any thicker? It looks thick. All right. So, that's giving me a hard time. So we have what is the this is something. Why type? I didn't want to type. Please bear with me. I don't know why it's making it so hard for me. We have stop there. Do not type. I don't want to type. So there is a in the formula for future value of annuity, we have payment. I mean, when, come on. There are times when, this keeps. There are times when future value is the unknown, payment is the unknown, and there are it's lost. There are times when rate is the unknown, and there are times when also there are times when n is the unknown, right? So we've covered this. We know how to do this. We know how to do this. Then we want to know how to find rate. We also want to know how to find n. So how do we do that? So let me just get to the, let me just cut to the chase. First, solving for n, and some people get daunted by this process. Look, the formula per se, the formula per se is this, right? And if you follow the math, it's just the steps of derivation, how to derive this formula, right, from the original future value of annuity formula, right? So some people, some students, just fret and ask me, Professor, do I need to memorize all that? Now, if you want to memorize, you just memorize the conclusion. If you know math, you know what these, three dots are. How many people know what? How many people know the meaning of three dots? What is that? The symbol? What does it symbolize? Anybody? Can anybody tell me what the three dots mean? In other words, why do I have two open? So you see what I'm saying? I'm talking about this. Do you know what this means? Anyone? This is just basic algebra, right? No? No one knows this? That means therefore. Okay? Thus or therefore. So then if you're saying therefore, then that's the conclusion. After therefore, then comes the conclusion. Right? And how many of you know, this was a point giver. This was a point giver, but how come nobody? And what about this? Does anyone know what this symbol means? Anyone? You're awfully quiet. I know you are there, but no one knows what this means. Now, this is like, a regular triangle. This is like, inverted triangle. Inverted, if regular triangle means therefore, inverted triangle means since, because. Okay? Now, then from that, you can easily tell, oh, this is the conclusion, right? So think about it. We need to solve for n. So what do we need to do? We will need to isolate. We'll need to isolate 1 plus r raised to n, but there is no way we can do it directly, right? We cannot do it directly. So we will need to simplify this or isolate whatever we can isolate first. So first, divide both sides by payment. So then, left-hand side will be FEA over payment, and you will have on the right-hand side only this. And then isolate. We need to isolate the numerator. So then, what do? We multiply both sides by r, by the denominator. So the left-hand side will become this, right-hand side will become this, and then we can move this 1 to the other side, right? Add 1 to both sides, so the right-hand side will become this, left-hand side, the left-hand side, right-hand side becomes this, and then we use natural law, right? We use natural law and turn this to z equals x times y format, and then we can solve for n, right? We can solve for n. Okay, so that's how you do how you solve for n in the future value of annuity. To the right, it's the how you solve for n in the present value of annuity. If there is a future value of annuity, there must be present value of annuity as well. We're going to talk about that later, but for now, this is how you solve for n. Now, you might think I skipped for r. No, what happened? No, I didn't skip for r. I didn't skip r. R is but for r there is no single unique mathematical process. In other words, we have to use the iterative process. For annuities, although it may seem not very scientific, but the only way we can do it is by trying out multiple trial and error method, right? Trying out several possible candidate numbers. But then again, the iterative process is what the computer is good for, right? Human brain cannot process like 1,000 calculations per second, but computers can execute like million calculations per second. In a split second, it can perform like 1,000 comparisons, 1,000 calculations. So in other words, it's gonna try out this number and see if it is, if it meets our condition, or if it meets our target or not. And then if it doesn't, it runs the loop again. If it does, it stops, right? It stops and outputs the result. But if it doesn't, it just runs the loop again over and over until it finds the solution. So that's what the computer is good for. So we'll use the Excel's built-in function for that. So here, now the next question is, okay, what should be the interest rate if we put, that will take us to 60K, right? Under this scenario, if you make, 859 deposit every month, then first we will need to find R, okay, and then well, of course this one is 60, and that R is periodic rate. So that's a periodic rate, meaning that's going to be that's monthly rate. So if we find the monthly rate, then we will just convert it into annual, right? So first, go to function and we scroll down to rate, okay, okay, and give it what it's asking for, n periods, 60, payment is there, and we enter it as negative. We enter it as negative because it's cash outflow, right? There is no present value because this is not a single cash flow model. This is not a single cash flow model. So there's no payment. There's no present value. Instead, we have payment. Future value, here's the future value. And type means, or whether it is ordinary annuity or annuity due. And I've been telling you, ordinary annuity is default unless otherwise stated. Default is ordinary, so we assume ordinary annuity. And what does that mean? Otherwise stated. So usually, the problem will tell you whether it is, ordinary. The problem doesn't tell you if it is ordinary, but if it is, annuity due, it will say the deposit is made or the payment is made at the beginning of each period. Right? Think about it. At the beginning of each period, that means what? That's the cue. That's the cue that this is annuity due. Now, what's the difference between annuity due and ordinary annuity? What's the difference between the two? What did I say? Anyone? What's the difference between ordinary annuity and annuity due? Does anyone remember that? No?
Is it the compound?
Yeah.
Yeah.
What about compounding? Yeah.
Like I know this because you just said it, but I forgot.
Yeah, well, I said one more compounding, just one more compounding, isn't that right? Just one more compounding. Annuity due has just one more compounding than ordinary annuity. So who was this? Who was this? Angelica, okay. Angelica, so you'll get 0.25. Okay, you get 0.25 for that. Yeah, so type, as I said, annuity due has one more compounding. So if it is annuity due, you put one there, right? You put one there, which means, one more compounding. But if it is ordinary annuity, you leave it blank. Because it's default, you leave it blank. Or just put 0. But, putting 0, leaving it blank is the same thing. We'll leave it blank. And guess means, what's your, guess. You don't need to. Not to guess, not to rely on any guesswork. That's why we are doing this. So you leave it. We already have 0.005 there. Hit enter. There you go. We got it. And then, so that's monthly rate. So how do we turn it into annual? We know. We annualize it by this time 12, right? So we got 6% already. Next. So how many years will it take? We know it's going to take 5 years or 60 months, but let's solve it by a formula. Of course, first we will need to find periodic rate, which is 0.5. And now we'll take natural log of FV over payment times R plus 1. I think that's it. Over natural log of 1 plus R. Let me just verify. Let me make sure that. Yes. Okay. So then hit enter. Wow, we got 60. Yeah, of course. And then how do we turn it into years? Of course, you divide 60 months by 12. Now we'll get you 5 years. Okay. Now let's do that. Let's do the remaining example, right? This $2,002 quarterly, right? So here first we'll need to fill in the missing input, which is, if you divide APR by quarter, right? 4. Okay. And then if you multiply 6 years by 4, you get, of course, 24 quarters. So first, let's find the how many. We know 20 is going to be 24 quarters, but let's confirm that. Let's verify and confirm. It's going to be natural log of 60K divided by payment times R plus 1, okay, divided by natural log of 1 plus R. And hit enter. Well, something's not right. What happened? Natural log of G13, right, over A13. Oh, E13 plus 1. 13 plus 1, right? Somehow I missed plus there. Yeah, gives you, it should, so it checks out 24 quarters. But you're not there yet because the problem is most likely asking in years. How many years, right? So we're going to divide 24 quarters by M, and that will give you 6 years. Now, how about rate? Again, then we're going to use Excel's built-in function. Okay. I already used rate, so I'm going to go to most recently used, and then rate is there. Hit OK. We'll give it number of periods. That's it. Enter. Payment. This is the payment, and we're going to make it. We have to make it negative because it's cash outflow. And there's no present value, as I said before. Future value, 60K. There you go. Type, it's ordinary, right? Unless otherwise stated, it's always ordinary because ordinary is the default. So we leave it blank. We don't even need to guess. We don't even need to, take any guess. You already gave us this. So hit OK. 1.88%. We converted into annual rate. I've been telling you over and over, all interest rates, all rates are basically expressed as annual. So we annualize it. In other words, we do that wasn't a keyboard. So we annualize it by this times n, and it should give you 7.5. Okay, so everyone got the same number? Tell me, do you have any? Oh, what's happening? Ah. Okay. Oh. As I said, I'm using my old computer, which is running on Windows 7, which was already, which is outdated, and they stopped the support of Windows 7, like 3 years ago. And now this is giving me such a headache. I thought it crashed. It looks like, it looked like a crash blue screen. They say, they call it blue screen of death. All right. So, any questions so far? Any questions? No? Did you all get the same result? Did you all get the same result?
Yes.
Okay, good, Angelica. But the rest of you, then, you didn't get the same result? Huh?
I did.
Okay, good, Naomi. Yeah.
I got the same result.
Okay.
We get
All
the
right,
result.
good.
Yeah.
Okay, good. Yeah, if you didn't get the same result, don't hesitate to ask, okay? Now, so you got all the same results, and we're almost out of time. So I will, I'll call it a day. Let's call it a day. Stop sharing. Have a great afternoon, everyone. Now we'll see you guys on Thursday, right?
Bye,
All right.
Professor. Have a good week.
All right, you too, Naomi, and I will stop recording and sign out.